Welcome back, Engine Performance Expo viewers. You know this guy, end gap. It's a question we get all the time. What should the end gaps be? So who better to ask than the guy who gapped the rings? Actually, I gapped the rings, but I did what you told me to do when we put together the Engine Performance Expo LS. So stay tuned. We're going to get into all the details of end gap. Okay, Jimmy, end gap. I mean, like we said, it is the most frequently asked question, and now there is a chart that comes with all the rings that says what you should do, but I know there's more to the story, so help us out.
Well, that's a guidance point. The top end gap is set basically whether it's a normally aspirated motor or it's a power adder motor, or what type of power adder motor.
Yeah, boost, nitrous makes a difference.
And what type of piston's in it.
That's right, because a hyper-eutectic piston is going to be hotter because it holds so much more heat.
Yes, and they recommend a much higher ring gap, and if you're using that piston, you've got to go by what they recommend.
Exactly.
Other than that, it's based purely on experience. That chart is a guideline, and you need to go by it, but always remember, looser won't get you in trouble, tighter will.
And that's the question we get, right, is how tight should it be? People tend to, I would say, in my experience, they overthink tightness. They try to make it too tight because they're worried that if they give up a couple thousandths of end gap, they're going to give up 3 or 4 CFM of blow by, and I don't see it in my experience.
I don't see it either, and I've run them all the way down to where I could actually see the grind marks on the opposite side of the ring. Mm-hmm. And a few times in the past 40 years, I've actually butted a ring and destroyed a cylinder.
Right, and that's never good.
You find out where the limit is,
mm-hmm.
and you back up from there. But I mean,
I said, a little extra gap doesn't really kill you.
Extra gap will not kill you. I mean, it's just like getting a bearing clearance too tight. It's the same as a ring. If you get it too tight, it's going to hurt something. A little bit loose is not going to hurt it. It won't help it, but it's not going to hurt it.
Essentially, it's margin of error. The tighter you get it, the less margin of error you have on your tune-up and operating environment. Because that's kind of the key, is it really is the operating environment that's going to dictate a lot of this.
And you can have this end gap perfect for a 900-degree cylinder or combustion temperature, mm-hmm. such as alcohol or something. But if that cylinder temperature gets to 1200 degrees, you better have a little extra in there to compensate for it, or it's going to butt the ring. And when it does, it tears stuff up.
Because really what we're saying is it's really about cylinder temperature.
Yes.
And that's where load really plays a big difference. And I think one of your best analogies is the difference between, a small block Chevy or even a big block Chevy in a boat versus a drag car. They're two totally different things.
Yeah, a drag car, even if it's a drag boat, the only thing out there with high gear only right now is a top fuel car.
Right.
But if you're in a boat, that's all you got. It's high gear only. And it's just like loading it against a dyno without pushing the feed button.
Yeah, you're just
letting it sit there. Because that's all you're doing. And the only gear ratio in that boat is the prop, depending on which one you put on it. And it never changes.
So the higher the load, the more heat.
The more heat you get on the piston.
So the more end gap you need to compensate for that.
Yes, and it's just like a turbo motor is going to have more heat than a normally aspirated motor. Just because there's more boost, there's more combustion temperature.
Right.
And, it's the same thing on a diesel motor. Like some of these racing Cummins engines with all this boost on them, I mean, they have to have huge end gaps on them. Because the piston dome gets so hot and it's such a high compression ratio. And if you put one into detonation, all bets are off then.
Oh yeah, exactly.
Because then the combustion temperature goes out of sight.
Yeah, you really can't help that. that's another problem you have to deal with. So, that's top end gap. So tell them a little bit about what we've seen with second ring end gap and the top oil rail end gap, because that's something that almost no one ever talks about, but is really important, is the end gap on that top oil rail as well.
Well, let's use for an example a blower motor.
Okay.
I have a nostalgia car that has a 427 in it. The top end gap on that motor, mm-hmm. because it's a filled block, has no water in it, top end gap on that motor is 36 thousandths.
Okay.
And,
on what bore size is that?
It's like a 4285 or something like that. And the second end gap should be quite a bit more than that. I mean, I've got an extreme on my motor, but it just shows you that and the reason it's so extreme is I couldn't get a ring closer to the bore than what I wound up with.
Got it.
Because it just wasn't available. So my second ring actually has 1/8 of an inch on it, 125 thousandths.
Wow.
But when you got a blower on alcohol, of course you don't have the cylinder temperature you do on gasoline, but
True.
But you're still going to have blow by if you've got a severely overdriven blower. So even though I have 125 on the second ring, the motor has very little blow by.
Right.
So the second ring is only acting as a scraper. Now,
Yeah, 80% of the second ring's job is actually to be oil control. 20% of it's actually sealing, and because they're offset, they're not lined up.
Right.
That top gap doesn't get to see that 125 thousandths directly.
right. Now, because I have that big a second end gap, I open the top oil ring rail up to give it a path for anything that goes by it to go into the pan.
Exactly.
And you still don't see it. And you only need to open the top ring because it gets into the oil return holes then.
Bingo, because that's the thing. In that oil return groove, right, the oil ring groove, there's holes where the oil can drain back into the sump. And that's the key, is you want to give it that path so that this pressure up here that gets by that top ring can get past the second ring and get into the oil ring groove and go out that oil return hole back to the sump.
So on the bottom ring, I like to stay between 15 and 20 thousandths.
Okay.
That'll work on pretty much anything.
Right, and that's pretty much standard. I think even the instructions from Total Seal
Say minimum
of 15.
When you get in a huge bore, like a 4650 or something like that, you may need a little more, but it's very minimal. Theoretically, my motor aside, I would want the second ring to always be bigger than the top, because if you trap the gas between the top and second, it will push the top ring off the seat at some point.
Yeah.
And same thing is you need the top oil ring to be marginally bigger or at least the same size as the second ring.
So they can kind of have that balance of flow.
I know the rings are supposed to seal the gases in the cylinders, but
nothing seals 100%.
Nothing seals 100%. And if you trap the gas between the rings, it will upset the ring seal.
Exactly.
And that's where you get all your ring flutter from.
And we saw that on the engine dyno when we were doing some oil development stuff. We saw that at that higher engine RPM, what made the biggest difference in increasing power, not really increasing power, but just not losing power.
I've actually been doing this on the engines that I used to build for probably 5 or 6 years. And it really helped the top end power on the motor.
Yeah.
To keep it from nosing over after peak power.
Yeah, it stabilized the top end.
It stabilized the top end. And for many years, I tried to keep it a secret.
Yeah, but it's kind of out
you
now.
can only keep an advantage for so long in this business because it gets out.
Oh, yeah.
You know, somebody else will get your motor and take it apart. And just like when I tear somebody else's motor apart, I want to see if I can learn anything.
Exactly.
Well, other engine builders have tore my engines apart and have asked the question why I did that.
Yeah.
And there's one thing about me. I'll either tell you the truth or I won't tell you.
There you go, exactly. Yeah. That's actually pretty kind, actually, right? Some people will tell you the wrong direction totally, so just being silent or telling you the truth is actually a pretty nice gift.
Yeah, so, you know, that's true with anything that I'm asked. I'll either tell you the truth or I'll just tell you I can't tell you.
I just remember seeing it when we first started doing it. It's like, wow, that made a big difference in stable. And it makes sense when you think about it. At higher RPM, past peak torque, there's less cylinder pressure to keep that top ring seated. So now that differential in pressure between that second ring and the top ring sees makes it easier to unseat that top ring. And when top ring unseats, blow by goes up, power goes down.
It's not necessarily unseating it from the cylinder wall.
No, it's from
all
the
it
ring
is
land.
it's pushing it up off the bottom of the ring land.
Bingo.
So, you know, it's not like you're blowing it off the cylinder wall.
No.
You're just pushing it up, building enough pressure between the first and second that the ring will raise off the ring land, and then it doesn't seal.
Right, exactly.
That's why a lot of the pistons have a bevel at the top on the top ring
Right.
that goes to the top is because when the combustion goes behind the ring, it blows it against the cylinder wall, just like same principle as a gas port.
Exactly.
But on a street motor, you run about 1.3 to 1.5 on the width of the ring, and where on the race motors we get down to 4 5 6/10 because they got gas ports on them.
Right.
And of course, then you get into all kinds of coatings and stuff to keep the rings from sticking or welding, but that's that's a different story.
Right, exactly. The general idea here is you want that second end gap wider so that you can let that gas pressure get down. Then you want to match that end gap with the top oil rail so that it can get down into the oil ring groove and be able to get through those oil ring or the oil return holes to get to the sump.
And there's not a set number on it. If it's a wet sump motor with no vacuum on it, you can open it up really
Pretty
big.
wide.
You know,
Yeah.
20, 30 thousandths bigger, don't hurt a thing.
Yeah.
Okay?
Well, I know on the Engine Performance Expo engine, that's a wet sump engine.
Yeah.
Because it's boosted and everything, we ran 32 thousandths on the top ring, I believe.
Yeah, and I think we ran 50 on the second.
Yeah, we did. And we opened that oil rail up that much too.
We opened the oil rail up to at least 50.
Yeah.
And, you know, the bottom rail was tight.
Yep.
As you know, for what it was. But now, that being said, if you got a dry sump motor that's open air, you can still do that. But if you've got something that's got a vacuum pump on it, a drag race motor, a round track motor that has a vacuum pump on it, you don't want to open it up quite as much.
Yeah, because now it's just going to be too much.
It still needs to be a little bigger than the top ring, and the oil ring still needs to be bigger than the second ring. But you don't want that 1/8 of an inch
Big
gap
giant
like I got in my drag cart, because you're going to lose part of your vacuum.
Yeah.
Even though you got good seals and all, it'll suck by the rings through the gap.
Yeah, so tighten it up
Now,
a little bit if you're running vacuum.
and if you're pulling big vacuum, it doesn't hurt nothing to have the total seal top ring.
No, it can pull a lot more vacuum
if you're pulling vacuum,
Yeah.
yes, I have no problem with that whatsoever. So there's
It actually works best in that application.
Well,
in my experience, right? If you're going to run that gap with top ring, that's where having a big vacuum system can make a big difference.
everything's a little different. You know, the marine engines are different from the drag motors. The dirt engines are different from the asphalt engines.
Yep.
Because they ingest. There's no way you can keep the cylinders clean.
No, there's dirt.
I mean, there's just
all
dirt.
the time.
I don't care how good a filter you got on it.
No, there's going to be just sand and stuff that gets in there, and it's going to wear on the cylinders. It's going to wear the rings. It's just going to happen.
I mean, yeah, you can run a tool steel or a stainless top ring in it and not wear the ring, but it's going to wear the ring land because it's going to get stuff in between it. It's just
Right.
There's a shorter rebuild time on the dirt motors just because of the dirt.
Oh yeah, I mean, think about it. Timken, they've said all along, the number one reason for a bearing failure of a rolling bearing or a plain bearing is dirt, it's contamination. So you're running in a dirty environment just by necessity, you're going to have a shorter operating life because it's a dirtier environment.
Well, the trick to that is lead the race.
That does help. Helps a lot.
But yeah,
Well, hopefully this little summary helped you guys out, because again, end gap's one of those questions you get all the time. There's lots of mystery. So hopefully this little segment here gave you some answers to kind of give you some perspective on what your top end gap should be, how to think about the second end gap, and take advantage of the little trick of setting your oil rail gap as well.
the big thing is just make sure that the second ring's bigger than the top, and the top oil rail is at least equal to the second, and don't make them too tight.
You heard it. You heard it from the man. He's been 277 miles an hour at Bonneville, so you should listen to him.
What a day, what a day, what a day. My brain is swollen. I've learned so much today. They told us, don't start cars. We are not going to listen.